Part 2, our review. Oh, here we're solving only few questions. Question number 13. Found potential function for vector field if you have vector fields as for example 3x squared y squared I plus 2x cubed y j. Well, first we need checking our vector field is conservative or not. This means we can find potential function or not. This function, how you remember, is function m. This is function m. We need found derivative, partial derivative function m respect to y. It will be 3x squared times 2y, who give this 6x squared y. Partial derivative for function n respect x, it will be 6x squared y. How you see this is equal? This means we can count potential function, and our potential function will be f. We take it integral from m part 3x squared y squared dx, and maybe, I'm not sure, we have some function who is depend only y. Okay, it will be equal. Let's give me x cubed y squared plus g depend only y. Okay. Found derivative this potential function for respect for y. It will be y. It will be 2x cubed y plus g prime y equal exactly function n, but function n is 2x cubed y. This means our g prime for y equals 0. It means gy can be only some constant c. And my potential function, it will be x cubed y squared plus c. Okay, great. Next question. Question number 14. Here we need evaluate integral. Okay, what is my question number 14? Let's prepare you. Yes. This we need evaluate line integral from x squared plus y squared plus z squared ds line c, whereas my c is t equal sine ci plus cosine cj plus 2k. How we evaluate our integral for this situation? Yes, and c changing from 0 to pi over 2. Okay, great. First we need found derivative rt. It will be cosine ci minus sine cj, and derivative 2 is 0. Norm this vector, it will be square root from cosine square c plus sine square c, who give me exactly 1. Okay, and move little bit up. And now we can plug our integral. Will be for x we plugging sine t, this means coefficient our vector I. For y we plugging cosine t, and for z we plugging 2. This means our integral t changing from 0 to pi over 2. How you remember we have x squared plus y squared plus z squared. This means it will be sine square t plus cosine square t plus z square give me 4, multiplied by norm r prime t, who is 1, and dt. Here we, well, first we simplify. Sine square plus cosine square is 1, plus 4 is will be 5 dt. It will be 5 t, where is 0, pi over 2. And final answer for 5 pi over 2. Okay. One more question about line integral. Here we need evaluate number 15. Evaluate this kind of integral. It will be 2x y z x plus, this means we work with vector field, plus x squared plus y squared z y. Okay, for some c, where c is curve ellipse, x squared over 25 plus y squared over 16 equal 1. And we need moving from point 50 to point 0,4. Okay. How does it work here? Here we need first found potential function. And we need checking, can we found potential function or not. M here is equal to xy, n equal x squared plus y squared, dm dy will be 2x, dn dx will be 2x, and this means our integral, 2x, right? This means I can found potential function because it's equal, because this is equal. This means here I found f from xy. It will be integral to x y dx plus maybe some part depend only y. Okay, we have, it will be x squared y plus gy. We need found gy. This means we found derivative our f function, potential function respect y. It will be x squared plus g prime y, and need be equal n function, n. This means this will be x squared plus y squared. Solving this equation, we have g prime from y equal y squared. This means g from y equal y cubed over 3. And our potential function fxy equal x squared y plus y cubed over 3. And my integral now, integral from line integral 2x y dx plus x squared plus y squared dy will be value, different value my potential function for point f from 0, 4 minus f from 5, 0, not 0, 5, sorry, 5, 0. Or we have, if we plug in 0, 4, we have 64 over 3. If you plug 5, 0, it will be 0. This means this is final answer. Okay, right? And my last question, it's use Green theorem. Okay, tell us how we can do it here. If we have, this is my last question, what number it was? I think it's 16. 16. We need to evaluate integral, use Green theorem, where you have cosine y dx plus xy minus x sine y dy for curve C, whereas C is some for region C, sorry, between something, a region between line y equal x and y equal square root of x. Okay. First we need to see what kind of object we have. We have y equal x and y equal square, sorry, square root of x. We need found interception. X equals square root of x. Equals 0. This means x equals 0, x equals 1. Okay, great. And now we need checking, this is our function m, this is function n, and our integral will be star equal double integral. Here we need x changing from 0 to 1, y change from x to square root of x, and differ partial, okay, dn and dx minus dn dy, and then we have dy dx. Okay, what this will be? dn dx for our situation, it will be 0, 1 x square root of x. It will be y minus sine y. dm dy, it's negative sine y. This means if I'm subtract, this will be positive sine y. And then I have dy dx. This is sine y and sine y cancel it. And I have integral from 0 to 1. Okay, write one more time. X to square root of x, y dy dx 0 to 1, it will be 1/2 here, y square x square root of x dx. 0, 1. Here we have x minus x square dx. Give me x square over 2 minus x cube over 3. 0, 1. It will be 1/2. 1/2 minus 1/3. Okay, it will be 1/6, 1/12. 1/12. This is all what I want to give you for review. Okay, all the work. I think it's very well for this difficult time. Good luck for your final, and see you in September. Okay, bye. Okay.